Hello everyone, I am Prakhya Jain, Assistant Professor, Department of Mechanical Engineering, HIT Mangalore. Today in this video I am going to discuss about problems related to fluid statics. First problem, a rectangular plane surface is 2 meter wide and 3 meter deep. It lies in vertical plane in water. Determine total pressure and position of center of pressure on the plane surface when its upper edge is horizontal and first one coincides with water surface, second one 2.5 meter below free water surface. So there is a rectangular plane surface that is kept vertically in water. There's a fluid is water here to keep rectangular surface vertical in water. So the depth of that rectangular surface is 3 meter and width is 2 meter. Determine total pressure, that is F you are supposed to find, and position of center of pressure, so that is H star, for two cases. That is first case when upper edge that coincides with water surface, and second case 2.5 meter below the free water surface, that is upper edge is 2.5 meter below the free water surface. Let's go for first case, that is upper edge coincides with water surface. Now draw rectangle in such a way that our depth is equal to 3 meter and width equal to 2 meter, and top edge or upper edge that coincides with free water surface. So diagram that looks like this, you can just see here. So and just mark points G and P. G is centroid of the plane surface, that's a rectangular surface, and P is center of pressure. So center of pressure at a distance of H star from pre-water surface, and center of gravity or centroid that is at a distance of H bar from pre-water surface. So let's go for solution. So total pressure is given by F equal to rho G into A into H bar. So where rho is density of fluid here it is water, density of water, because rectangular surface or plane surface that is kept in water, and G is acceleration due to gravity, A is area, H bar is distance of centroid from free water surface, where rho equal to 1000 kg per meter cube, G equal to 9.81 meter per second square, A equal to B into D, so that is equal to 2 into 3. So width is 2 meter and depth is 3 meter. So 2 into 3, that is equal to 6 meter square. Now H bar, that is distance of centroid from free water surface, that is equal to 3 by 2, that is equal to 1.5 meter. So you can see the object, this rectangular plane surface. So overall depth is 3 meter. Centroid, it lies exactly at the 50% of this area. So 50% of 3 meter, that is 1.5, or 3 by 2, that is equal to 1.5. So H bar equal to 1.5 meter. Therefore F equal to 1000 into 9.81 into 6 into 1.5, that is equal to 88,290 Newton. So that is total pressure. Now depth of center of pressure is given by, there's a correlation, you have to remember this, H star equal to Ig divided by A into H bar plus H bar. So where Ig equal to moment of inertia about centroid or center of gravity of area of surface. So that is given by rectangular plane surface, moment of inertia for rectangular plane surface, that is Ig equal to BD cube divided by 12. So B, that is width, that is 2 meter, depth, that is 3 meter. So 2 into 3 cube divided by 12, that is equal to 4.5 meter to the power 4. So then therefore H star equal to 4.5 divided by 6 into 1.5 plus 1.5, that is equal to 2 meter. So there is a distance of a center of pressure or a center of pressure from free water surface. So there is a S star. So next case, upper edge is 2.5 meter below water surface. So free water surface you are supposed to draw first. Now upper edge at a distance of 2.5 meter below water surface. So just maintain a gap of 2.5 meter. Then draw rectangle that is similar to previous case. So with the depth equal to 3 meter and width equal to 2 meter. So that is now mark G and P. G is centroid or center of gravity and P is center of pressure. Now P it is at a distance of H star from water surface, and G it is at a distance of H bar from water surface. So now total pressure is given by F equal to rho G into A into H bar, where H bar equal to distance of center of gravity from free surface of water. So I have to remember this, the h bar equal to distance of center of gravity from free surface of water. In previous case, upper edge was coinciding with free water surface, so there was no problem. But in this case, center of gravity, so it is at a distance of h bar from free water surface. Now G can be found easily from rectangular shape that exactly lies at 50% of the depth. So that is 50% of 3 meter, it is 1.5. So just mark G. Below that there is a point P, that is the center of pressure. Now to calculate distance from free water surface. So from free water surface to upper edge there is a gap 2.5 meter. So 2.5 meter plus 1.5, that becomes 4 meter. So h bar equal to 2.5 plus 3 by 2, that is equal to 4 meter. Therefore F equal to 1000 into 9.81 into 6 into 4, that is equal to 235440 Newton. Next, center of pressure is given by H star equal to Ig divided by A into H bar plus H bar. So that is equal to 4.5 divided by 6 into 4 plus 4, that is equal to 4.1875 meter. So that is center of pressure. Next, second problem, determine total pressure on a circular plate of diameter 1.5 meter which is placed vertically in water in such a way that the center of the plate is 3 meter below the free surface of water. Find the position of center of pressure. So first you are supposed to find F, there is a total pressure, then center of pressure you are supposed to find. So here this problem is related to circular plate of diameter 1.5 meter. Again, this is a vertical condition, vertically submerged plane surface in fluid. Fluid is water here also. So the center of plate is 3 meter below the free surface of water. So just draw a circle in such a way that the center of the circle at a distance of 3 meter from free water surface. Then P that lies below center of gravity, that is at a distance of h star from free water surface. Now diameter of the plate D equal to 1.5 meter. So area, you know how to find area of circular object. So A equal to pi by 4 D square. So that is equal to pi by 4 into 1.5 square. So that is equal to 1.767 meter square. Now H bar, it is directly given in problem. The center of circular plate, it is at a distance of 3 meter from free surface. So h bar equal to 3 meter, directly you can take. So h bar equal to 3 meter. Now you can find total pressure, F equal to rho g into A into h bar. Now F equal to 1000 into 9.81 into 1.767 into 3. So that is equal to 52002.81 Newton. Now center of pressure is given by S star equal to Ig divided by A into h bar plus h bar, where Ig equal to pi into d to the power 4 divided by 64. This you are supposed to remember. For rectangle it was bd cube by 12. So that is for rectangular shape. Now here for circular plate, Ig, that is moment of inertia about centroid. So that is equal to pi d to the power 4 divided by 64. So d is 1.5. So just calculate moment of inertia. So that is equal to pi into 1.5 to the power 4 divided by 64. That is equal to 0.2485 meter to the power 4. Now S star equal to 0.2485 divided by 1.767 into 3 plus 3, that is equal to 3.0468 meter. Just by substituting in formula, you are going to get S star equal to 3.0468 meter. Next problem. An isosceles triangular plate of base 4 meter and altitude 4 meter immersed vertically in an oil of specific gravity 0.9. The base of the plate coincides with free surface of oil. Determine, first one, total pressure on the plate, second one, center of pressure. So solution, it is better to draw the diagram here. So there is an isosceles triangular plate. So upper edge or the base of that plate, that is going to coincide with free surface of oil. So draw a triangle in such a way that the base of the triangle that coincides with free oil surface. So with base equal to 4 meter and height equal to 4 meter. So just locate G and P. So P always that lies below the center of gravity. Next, base of the plate that is given as, take it as B, that is equal to 4 meter. Height of the plate, take it as H, so that is equal to 4 meter. Therefore area equal to, area of the triangle, that is equal to half into base into height. So base it is given as 4 and height it is given as 4. So 1 by 2 into 4 into 4, that is equal to 8 meter square. So specific gravity of oil, that is S equal to 0.9, it is given. So the triangular plate that is immersed or submerged in liquid of specific gravity 0.9 instead of water. So just calculate density. Density of oil equal to 0.9 into 1000. So that is equal to 900 kg per meter cube. The distance of center of gravity from free surface of oil. So that is equal to h bar equal to 1 by 3 into h, so that is equal to 1 by 3 into 4, that is equal to 1.33 meter. This is also you are supposed to remember the center of gravity for triangular plate that lies at a distance of 1 by 3 h. H is that corresponds to height from the base. So base you see there, you can see there it coincides with free water surface. So center of gravity, it lies at a distance of 1 by 3 h from base of triangle, that you are supposed to remember. So h bar equal to 1 by 3 into h, so that is equal to 1 by 3 into 4, that is equal to 1.33 meter. Therefore total pressure is given by F equal to rho g into A into h bar. So therefore F equal to 900 into 9.81 into 8 into 1.33, so that is equal to 93,940.6 Newton. So that is total pressure. Now center of pressure is given by H star equal to Ig divided by A into h bar plus h bar, where Ig equal to moment of inertia of triangular section about its center of gravity. So that is equal to bh cube divided by 36. You have to remember this one also. For various shapes you are supposed to remember moment of inertia. Rectangle, triangle, circle and square you are supposed to remember here. Anyhow, I explained about that thing in tabular column. So where Ig equal to moment of inertia of triangular section about its CG. So that is equal to bh cube divided by 36. So that is equal to 4 into 4 cube divided by 36 equal to 7.11 meter to the power 4. Therefore h star equal to 7.11 divided by 8 into 1.33 plus 1.33, that is equal to 1.99 meter. So that is position of center of pressure. Next problem, a square aperture in the vertical side of a tank has one diagonal vertical and it is completely covered by plane hinged along one of the upper sides of the aperture. The diagonals of the aperture are 2 meter long and a tank contains a liquid of specific gravity 1.15. The center of aperture is 1.5 meter below the free surface. Calculate the thrust exerted on the plate by the liquid and position of center of pressure. So there is a square aperture in the vertical side of tank, has one diagonal vertical. So you have to keep one diagonal vertical here. So that can be done by keeping square in corner condition. So one diagonal vertical. So diagonal length it is given as 2 meter. So as this is a square, so diagonal lengths are equal. So diagonal, that is AC equal to 2 meter and BD equal to 2 meter. And the tank contains a liquid of specific gravity 1.15. This is specific gravity S equal to 1.15 it is given. The center of aperture is 1.5 meter below the free surface. So center of aperture, always remember distance from center to free water surface, that is taken as H star, H bar. So that is position of center of gravity from free surface. So h bar it is given as 1.5 meter. So directly you can take, calculate the thrust exerted on the plate by liquid and position of center of pressure. F and H star you are supposed to find here. Solution, you need not draw this diagram. There's a diagram of tank. You can directly draw a square in corner condition and you can just write down the given data, that is diagonal length 2 meter and from free water surface distance is 1.5 meter to center of the square, this square. So you can just draw that diagonal of aperture, that is AC equal to BD equal to 2 meter, that is given in problem. Area of the square aperture, so you should be careful while calculating area of this square. So it is not side square. Area of the square aperture A equal to area of the triangle ACB. So you can see here diagonal length is given, it is not the length of the side. So the diagonal length, that is AC equal to BD, it is given as 2 meter. If side length is given, means you can directly calculate area equal to side square. Now it is not the case, diagonal length is given. So area of this shape can be calculated by dividing this square in corner condition into two triangles, that is area of triangle ABC and area of the triangle ADC. So you know area of the triangle, that is half into base into height. Similarly, you have to calculate area for two portions. So here area of the square aperture A equal to area of triangle ACB plus area of triangle ACD. So area of the triangle ACB equal to AC into base, that is the AC, a base into height, that is into BO divided by 2, half into base into height. Similarly, for triangle ADC, base is AC and height is OD. So 1 by 2 into AC into OD. So that is equal to AC, that is given as 2 meter diagonal length. So BO, that is actually 50% of another diagonal, that is diagonal BD. So BO equal to OD equal to 1 by 2 of BD. So it is 1. So 2 into 1 divided by 2 plus 2 into 1 divided by 2, that is equal to 2 meters square. Specific gravity of liquid, that is given as 1.15. Therefore density of oil equal to 1.15 into 1000. So that is equal to 1150 kg per meter cube. The distance of center of gravity from free surface of oil, that is equal to h bar. It is given in problem. So that is equal to 1.5 meter. The thrust on plate is given by, that's the total pressure, F equal to rho g into A into h bar. So therefore F equal to 1150 into 9.81 into 2 into 1.5, that is equal to 33,844.5 Newton. Center of pressure is given by H star equal to Ig divided by A into h bar plus h bar, where Ig equal to moment of inertia of ABCD about diagonal AC. So why diagonal AC? Diagonal AC, that is a diagonal passing through center of gravity. Now it is very difficult to find moment of inertia. A moment of inertia for this shape can be calculated by dividing this shape into two portions, that is triangle ABC and triangle ADC. So you have to calculate moment of inertia of ABCD by calculating moment of inertia of triangle ABC and ADC about its base. Base is AC here. So that can be done like this. Moment of inertia of triangle ABO about AC plus moment of inertia of triangle ACD about AC. So that is BD cube divided by 12. So AC, base is AC, and OB, that is the height for triangle ABO. So OB cube divided by 12. Similarly, AC into OD cube divided by 12. So you have to remember here it is with respect to base. So base of the triangle, it is not centroid. If you are going to take centroid BH cube divided by 36, then it goes absolutely wrong. So here this moment of inertia of this shape, that is square in corner condition, that can be calculated by calculating moment of inertia of triangles about its base. Base is AC, it is given in problem. So we are going to get 2 into 1 cube divided by 12 plus 2 into 1 cube divided by 12, that is equal to 1 by 3 meter meter to the power 4. So because moment of inertia of triangle about its base equal to BH cube divided by 12, because AC is a base, not centroid. So I have to calculate with respect to base. So H star equal to 1 by 3 divided by 2 into 1.5 plus 1.5, that is equal to 1.611 meter. So that is the position of center of pressure from free surface, that is equal to 1.611 meter. Next, fifth problem. A rectangular plane surface 2 meter wide and 3 meter deep lies in water in such a way that its plane makes an angle of 30 degree with the free surface of water. Determine total pressure and position of center of pressure when the upper edge is 1.5 meter below the free water surface. So this problem is related to inclined plane surface. So a plane surface is rectangular in shape with 2 meter width and 3 meter deep. Lies in water, so it is submerged in water in such a way that its plane makes an angle of 30 degree with the free surface of water. Determine total pressure, that is F, and position of center of pressure, that is S star, when upper edge is 1.5 meter below the free water surface. So keep rectangle in inclined position. So here 3 meter deep, so it is given rectangular plane surface 2 meter wide and 3 meter deep lies in water in such a way that plane makes 30 degree with the free surface of water. So here keep rectangle in inclined position. So 3 meter as height and 2 meter as width. So it makes an angle of 30 degree with free surface of water. So draw one inclined line. The angle theta is 30 degree. And upper edge, that is distance from C to D, that is taken as 1.5 meter below the free water surface. It is given in problem. Then mark G and P. It is similar to a derivation of inclined plane surface. Just mark G and P and write 3 meter, 2 meter. Then from P, just project one line, and G also project line. So projection line from B, that means at B, and projection line from G, that means that some point. It is not mentioned in the diagram. So H star, just not write H star and H bar, and just for calculation purpose write E and D and C. So DC, that is given as 1.5 meter. So let's go for solution. Width of plane surface B equal to 2 meter. Depth D equal to 3 meter. Angle theta equal to 30 degree. Distance of upper edge from free water surface, that is DC, equal to 1.5 meter. Total pressure is given by F equal to rho G into A into H bar. So where rho equal to 1000, because it is submerged in liquid. That liquid is water. So density equal to 1000 kg per meter cube. G is acceleration due to gravity. So that is equal to 9.81 meter per second square. So area, that is similar to previous problem, width into depth. So that is equal to B into D, that is equal to 2 into 3, that is equal to 6 meter square. Now you are supposed to find H bar. So sine 30, that angle theta, it is given as 30 degree. Now how to find H bar? So for H bar, I have to consider one triangle first. So triangle that is BCE. So C, that is BCE. In triangle BCE, you angles C, that is equal to 30 degree, because it's a corresponding angle. So BCE, that is equal to 30 degree. So just apply sine 30. Sine 30 equal to opposite by hypotenuse. So what is opposite by hypotenuse here? Opposite is EB. So EB divided by hypotenuse, that is BC. So what is BC now? BC, that is centroid. Distance from top edge, that is 1.5. Overall depth is 3 meter, it is given. So 3 by 2, that is 1.5 meter. So BC equal to 1.5 meter. So sine 30 equal to EB divided by 1.5. So EB, what is EB now? EB equal to okay. So sine 30 equal to EB divided by BC. So EB equal EB divided by 1.5. Therefore EB equal to 1.5 into sine 30. Sine 30 is 0.5. So 1.5 into 0.5, that is equal to 0.75 meter. Now H bar. Now you can see the diagram. H bar equal to EB plus DC. So you can just see the diagram. H bar equal to EB plus DC. DC, it is known 1.5. EB you just now calculated, that is equal to 0.75. So H bar, it is a summation of EB and DC. So that is equal to 1.5 plus 0.75, that is equal to 2.25 meter. That is H bar. Now therefore F equal to 1000 into 9.81 into 6 into 2.25, that is equal to 132435 Newton. Now center of pressure is given by H star equal to Ig divided by A into H bar plus H bar, where Ig equal to BD cube divided by 12. So that is for rectangular shape. So that is equal to 2 into 3 cube divided by 12. So that is equal to 4.5 meter to the power 4. Therefore H star equal to 4.5 divided by 2 into 2.5 plus 2.5, 2.25, that is equal to 2.333 meter. So H star, by directly substitution in formula, that is H star equal to Ig divided by A into H bar divided plus H bar. So H star equal to 4.5 divided by 2 into 2.25 plus 2.25, that is equal to 2.33 meter. That's the position of center of pressure. Now next problem, very important problem. So many times they are asked in exam, final exam. So there is a problem related to circular plate. So a circular plate 3 meter diameter is immersed in water in such a way that its greatest and least depth below the free surface are 4 meter and 1.5 meter respectively. Determine total pressure on one face of the plate and position of center of pressure. So solution. So keep a circle in inclined position and draw inclined line, that is OB. Just draw OB. Then freeze water surface. Then diameter you can just represent, that is 3 meter. Then just project these circle to inclined line. Just draw the mark the points B, G, C and O, and the distance you just mark BE, that is greatest length, greatest depth, it is given as 4 meter, and lowest depth you can see CD, that is the lowest depth, that is 1.5 meter. So EB equal to 4 meter, DC equal to that is 1.5 meter. Then center of gravity G, you just mark GF there for it will simplify your calculation. So now just first initially keep circle in inclined position, then draw OB, then greatest depth and lowest depth, and free water surface. Now diameter of the plate D equal to 3 meter, therefore area equal to pi by 4 D square, so that is equal to pi by 4 into 3 square, so that is equal to 7.0685 meter square. This is the area of circle. So distance DC equal to 1.5 meter, you can see there DC, that is a lowest depth, least depth of immersion, that is given in problem, so 1.5, and greatest depth, that is B equal to 4 meter. So it is always like that only, you just remember least depth and greatest depth. So from triangle ACB, so ACB, theta it is not given in this problem, you have to calculate theta first, then you can go for calculation of H bar. So from triangle ACB, so ACB, you can see there ACB, I represented there point C, so C ACB, so sin theta, that is AB divided by that is hypotenuse BC. Now what is BC? BC it is equal to diameter of circle, that is 3 meter. So sin theta equal to AB divided by BC. Now what is AB? AB equal to, so you can see there 4 minus 1.5 meter. So 4 minus 1.5, you total EB is 4 meter, CD equal to AE, so that is equal to 1.5 meter. So AB can be obtained 4 minus 1.5. So AB equal to BE minus DC or BE minus EA divided by BC. So that is equal to 4 minus 1.5 divided by 3. So that is equal to 0.8333. So sin theta, you need not calculate theta by like a sine inverse. You just keep sin theta equal to 0.8333 as it is. Next, apply for another triangle FCG. So you can see the FCG equal to theta, angle theta. So again apply sin theta. Sin theta equal to, that is FG divided by hypotenuse, that is GC. Now GC it is 50% of diameter, that is 3 meter. 50% of 3 meter, that is equal to 1.5. Now what is FG? FG equal to, so total is H bar minus DC. So H bar minus DC, what is DC? DC is 1.5. So sin theta equal to H bar minus 1.5 divided by 1.5. Therefore H bar equal to, just cross and multiply 1.5 sin theta plus 1.5. So sin theta value we already obtained it as 0.8333. So H bar equal to 1.5 into 0.8333 plus 1.5, that is equal to 2.749 meter. So that is H bar. So total pressure is given by F equal to rho G into A into H bar, where rho equal to 1000 kg per meter cube, G equal to 9.81 meter per second square. F equal to 1000 into 9.81 into 7.0685 into 2.749, that is equal to 190621 Newton. Therefore center of pressure is given by S star equal to Ig divided by A into H bar plus H bar. So Ig, we already calculated this thing in previous problem, pi d to the power 4 divided by 64. So that is equal to pi into 3 to the power 4 divided by 64, that is equal to 3.976 meter to the power 4. S star equal to 3.976 divided by 7.0685 into 2.749 plus 2.749, that is equal to 2.891 meter. This is the position of center of pressure from free surface. Next, seventh problem. Find total pressure and position of center of pressure on triangular plate of base 2 meter and height 3 meter, which is immersed in water in such a way that the plane of the plate makes an angle of 60 degree with the free surface of water. The base of the plate is parallel to water surface and at a depth of 2.5 meter from water surface. So this problem is again related to inclined plane surface. So plan, what is plan? Plan means it's the top view. So top view makes an angle of 60 degree. So you can just see there. So keep the triangle in inclined position. So mark P and G. So P and G point here. Then it is given the base of the plate is parallel to water surface and at a depth of 2.5 meter from water surface. From water surface, you just mark 2.5 meter. That is point Q at a point A at a distance of 2.5 meter from surface. That is a free water surface. Then H star, that's P, the location of P from inclined plane to free water surface. Then H bar, that is from G, distance from plan of the surface to a free water surface. Angle theta, it is given as 60 degree in problem. So just consider one triangle here. I'll explain about that triangle later. Now base of the plate, that is given as B equal to 2 meter. Height of the plate H equal to 3 meter. It is given in problem. Now you can calculate the area. Area equal to half into base into height. So that is equal to 1 by 2 into 2 into 3. That is equal to 3 meters square. Now inclination theta equal to 60, it is given. Now depth of center of gravity from free water surface you are supposed to find. Now how to find? This is again similar to circular plate inclined with some angle theta. So you have to apply the sin theta concept here also. From triangle QAG. So you can see here least depth is only given, not greatest and least depth together it is given in this problem. One least depth of immersion it is given. So consider one small triangle. So that is with respect to, that should consider H star. H bar. So that is triangle triangle GQA you just consider. So you can see the enlarged view inside side, that is angle GAQ, that is equal to 60 degree. Now what is QG? QG equal to H bar minus 2.5 meter. So H bar minus 2.5. So sin theta equal to H bar minus 2.5 divided by, what is the hypotenuse? Hypotenuse is AG. Now you are supposed to find AG. How to find AG? So AG equal to, that is distance from G to the base of the triangle. So that is AG equal to 1 by 3H from base. You know, centroid of triangle that lies at a distance of 1 by 3H from base. I have used this correlation in second problem. So just recall. So AG equal to 1 by 3H from base. So base 1 by 3 H is, it is given as 3 meter. So 1 by 3 into 3, that is equal to 1 meter. So H equal to 1 meter. So sin 60 equal to H bar minus 2.5 divided by 1 meter. So you can just cross multiply and rearrange and you can get H bar. So sin 60 equal to H bar minus 2.5 divided by 1. So H bar equal to sin 60 plus 2.5. So that is equal to 3.366 meter. Total pressure is given by F equal to rho G A into H bar. Therefore F equal to 1000 into 9.81 into 3 into 3.366. So that is equal to 99061.38 Newton. Center of pressure is given by H star equal to Ig divided by A H bar plus H bar, where Ig equal to moment of inertia of triangular section about its CG. That is equal to BH cube divided by 36. So that is equal to 2 into 3 cube divided by 36. That is equal to 1.5 meter to the power 4. Here you can see it is a moment of inertia with respect to CG. Only in square in corner condition you have to consider with respect to base. So here it is with respect to CG. So that is equal to BH cube divided by 36. So that is equal to 2 into 3 cube divided by 36. That is equal to 1.5 meter to the power 4. Therefore H star equal to 1.5 divided by 3 into 3.66 plus 3.366. That is equal to 3.477 meter. So there is a position of center of pressure from free water surface. Next, 8th problem. A caisson for closing the entrance to a dry dock is of trapezoidal form, 16 meter wide at the bottom and 10 meter wide at the top and 6 meter deep. Find the total pressure and center of pressure on caisson if the water on the outside is just level with the tap and dock is empty. So this is the question asked in December 2014. Solution: this is the form of trapezoid. You know the shape, how the shape of trapezoid looks like. So just draw one trapezoid with top being 10 meter. It is given 16 meter wide at the bottom and 10 meter wide at the top. So 10 meter wide at the top and 16 meter wide at the bottom. Then depth it is given as 6 meter. So A equal to, just take top edge as A and bottom edge as B. So A equal to 10 meter, B equal to 16 meter and depth that is that is equal to height, that is H equal to 6 meter. The area equal to 1 by 2 into A plus B into H. So you have to remember this correlation from the tabular column. So area equal to A equal to 1 by 2 into A plus B into H. So that is equal to 1 by 2 into 10 plus 16 into 6 equal to 78 meters square. So H bar, this is again correlation you have to remember from tabular column for trapezoidal shape. So H bar equal to 2A plus B divided by A plus B into H by 3. So that is equal to 2 into 10 plus 16 divided by 10 plus 16 into 6 by 3. So that is equal to 2.7692 meter. Therefore total pressure is given by F equal to rho G A into H bar. So therefore F equal to 1000 into 9.81 into 78 into 2.7692. So that is equal to 2.1189 into 10 to the power 6 Newton. Center of pressure is given by H star equal to Ig divided by AH bar plus H bar, where I is equal to moment of inertia of trapezoid about this centroid. So that is equal to A square plus 4AB plus B square divided by A plus B into 36 into H cube. So this is also correlation you have to remember from tabular column. So that is equal to 10 square plus 4 into 10 into 16 plus 16 square divided by 10 plus 16 into 36 into 6 cube. So that is equal to 229.8461 meter to the power 4. Therefore H star equal to 229.8461 divided by 78 into 2.7692 plus 2.7692. So that is equal to 3.833 meter. So this is center of position of center of pressure from free water surface. Next, last problem, very important one. So they asked this question in June 2016 and July 2016. So one is circular plate, other one circular plate with a hole. Those are the two problems, possible important problem from this section. So an annular plate 3 meter external diameter, that is DO, it is given, and 1.5 meter internal diameter, that is DI, is immersed in water with its greatest and least depth below water surface R, 3.6 meter and 1.2 meter respectively. Determine total pressure and position of center of pressure on one face of the plate. So this was the question asked in June 2015 and July 2016. So lowest depth and least depth and greatest depth, that is DC, it is given as 1.2 meter and EB it is given as 3.6 meter. So this diagram is similar to previous problem. So you can just write diameter of the plate DO equal to 3 meter, DI equal to 1.5 meter, area equal to pi by 4 into DO square minus DA square. It is a circular plate with a hole. So I have to subtract that whole portion. So pi by 4 into DO square minus DA square. So that is equal to pi by 4 into 3 square minus 1.5 square. So that is equal to 5.3014 meter square. Now distance DC, that is given as 1.5 meter and B equal to 4 meter. So from triangle ACB, sin theta equal to AB divided by BC. So AB divided by BC. So AB can be calculated as 4 minus 1.5. So that is B minus DC divided by BC. So that is equal to 4 minus 1.5 divided by 3. So that is equal to 0.833. There is the value of sin theta. From triangle FCG to calculate H bar. So sin theta equal to H bar, that is H bar minus DC divided by GC. So that is opposite divided by hypotenuse. Opposite is FG. So FG, that is the equal to, you can see there, H bar minus 1.5. So H bar minus DC. So H bar divided by GC, that is equal to, GC is hypotenuse. So GC, that is 50% of diameter. The 50% of 3 meter, that is 1.5. So H bar minus DC divided by GC. So that is equal to H bar minus 1.5 divided by 1.5. Just rearrange. H bar equal to 1.5 sin theta plus 1.5. So that is equal to, sin theta value it is 0.833. So 1.5 into 0.833 plus 1.5. So that is equal to 2.749 meter. So this is the value of H bar. Now total pressure is given by F equal to rho G A into H bar. So where rho equal to 1000 kg per meter cube because it's water. So G equal to 9.81 meter per second square. Now F equal to 1000 into 9.81 into 5.3014 into 2.749. So that is equal to 142966.5 Newton. Center of pressure is given by H star equal to Ig divided by A into H bar plus H bar. So where Ig equal to, here also you should be careful to subtract that whole portion. So pi into d to the power 4 minus di to the power 4 divided by 64. So that is equal to pi into 3 to the power 4 minus 1.5 to the power 4 divided by 64. So that is equal to 3.7275 meter to the power 4. H star equal to 3.7275 divided by 5.3014 into 2.749 plus 2.749, that is equal to 3.004 meter. So there's a value of position of center of pressure from free water surface. So these are the problems related to fluid statics. So this the portion is related to chapter 2 of first module. Okay, thank you.